Welcome to Weird Science. Absolutely. Thank you for the 100. What's up, Streamroller? How are you? Welcome to Weird Science. Hey. Good to hear it, Neil. So I encourage everybody to do the same. Go check out Esther's GoFundMe. It's on my LinkedIn bio, or not LinkedIn, my Instagram bio. Yeah, she's going through a rough time and she could use all the help she can get. Please donate if you can. Pray for her and just hope that everything gets better for her. Fish. Kim Possible. I'm sure it's impossible to get anything more than dolphins around here. Welcome. This is Weird Science, and I'm Mike F. Bell, and we're going to be talking about some interesting stuff. I hope everybody is doing well. What's up, Sparky? What's up, Kim? Yeah, the dolphins, they should be a bonus, but they are not, unfortunately. But hey, maybe that's a suggestion to meet me. I do not know. Anyway, first up, I just wanted to say hi. Welcome to Weird Science. I'm your host, Mike F. Bell, and we're talking about hydraulics today. But first, we're going to be talking about space news. In the space news, we had a launch of the SpaceX Falcon 9 with another 60 Starlink satellites. And that actually took place the Thursday, just the previous Thursday, so a little less than a week ago. But I have the footage of the launch, and I wanted to share that with you guys. So let's go ahead and start that.
And watch as Falcon 9 takes our stack of Starlink satellites into orbit.
Welcome, Ghost.
T-minus 15 seconds.
Thank you for the raised hands. How are you?
10,
9, 8, 7, 6, 5, 4, 3, 2, 1.
Ignition.
There we go. Lift off. And this is starting to become a little commonplace as space travel. No, this is actually SpaceX. This is SpaceX's Falcon 9 with 60 Starlink satellites. Hey, Disney. What's going on, Alexi? How are you?
Here we see Falcon 9 has successfully lifted off from Cape Canaveral Space Force Station, carrying our stack of Starlink satellites into orbit. There we just heard that power and telemetry are all nominal.
Everything is nominal, and it will be nominal. You have
this is the largest structural load that the vehicle will see during ascent, so slowing the vehicle down a little helps during that.
These nighttime launches are always so awesome. Every time I watch one of these, I live in Tampa, which is on the other side of Florida, and even still, on a night launch, these are bright enough to light up the sky all the way here in Tampa. It's really
Round of applause
fantastic.
For Max Q. Now, in about a minute, the next three events will be happening back to back. First, we have main engine cutoff or MECO, and that's where all 9 of the M1D engines that are currently firing will shut down. And this will help
Main
slow the
engine?
vehicle down in preparation for stage separation.
Space
which is event
Coast.
number 2. And
That's awesome. You
And
should
as the
totally
name
come on
suggests,
as
there's separate
a
stages
correspondent
that
and
separate from each
be
other.
like,
And
coming to you
first stage will
live
start to
from,
make its way back to
yeah,
the
it could be
engine
cool. It's,
for landing on our drone ship. While second stage continues its journey with the third event, SES1 or second engine start 1. This is where the MVAC engine will light up and begin to propel the second stage along with those Starlink satellites to orbit.
Really? Nice. I would like to. That would be
That
cool.
main engine cutoff event is taking place in about 10 seconds. Great shot there of the vehicle prior to MECO.
But you're only 21, so how's that even possible? You would have been 16. Main engine cutoff and then stage separation.
Stage separation confirmed.
And then they have the start of the second engine,
all three of
second
those
engine
events
start.
happening in quick succession prior to MVAC ignition there that you see caught a glimpse of. Oh, and on the left-hand side of your screen, you can see the Space Coast illuminated by the night lights. That's an awesome shot.
It is
As we
really
see the
awesome.
grid fins beginning their deployment. So everything looking great there on second stage.
Okay, separation confirmed.
The verbal call out, and there on your screen you can see.
Trajectories.
All right, great news all around. We had fairing separation. Those will we
No
were attempting
worries.
to recover those using our recovery vessels. Then we heard everything looking nominal for both first and second stages. Dark on the left hand side.
No,
of your screen
everybody
there,
is
so
smart.
let's
Like, it
switch
doesn't
to
matter the
night
age.
lights.
My son is a prodigy.
Is going to be coming back down and making a landing.
6 years old, and he's able to do algebra, and he's able to read and write at a high school level.
The entry burn, where 3 of the M1D engines will reignite. This will help to slow the stage down as it re-enters the upper part of the Earth's atmosphere. The second burn is the landing burn, and that is
I am.
a single engine burn.
He's actually very good at it.
Reignite the center engine, and that will
Jamil,
help
what's
bring
going
the
on?
vehicle speed down rapidly in order to make a soft landing on our drone ship. Of course, I still love you.
Of course, I still love you. The drone ship that they're able to
Everything continues to
land
look
on.
great there.
It's
Trajectory looking nominal for second stage.
so what's going on
Of
is
that MVAC nozzle.
they're burning and they're trying to get into orbit with the second stage. Second stage is all about increasing that forward velocity in order to
So at this point
make
in
your
time,
trajectory.
first
So
stage,
you're actually
Trajectories.
your trajectory is over
this
the
stage is
side of the
now
planet.
beginning to descend back to Earth. It is equipped with 4 hypersonic
Yeah, you're
engines
faceless.
that are positioned near the top of the first stage. We don't have any light illuminating the vehicle at the moment, so can't really make them out on camera. So we're providing you views of our second stage instead. But those grid fins that we saw deploy earlier are what stage 1 uses to help steer as the stage makes its way back to Earth. They help orient and guide the booster during reentry and during descent.
It's so awesome. And that glowing red that
Additionally,
you
the
see
first
from
stage
the
will
engines, it's all
occasionally
from.
use nitrogen gas bursts for attitude control.
What's up, Garrett? How are you?
And
Good to
less
see you,
visible
sir.
At night, but certainly during our daytime launches, you can see the little white puffs near the top of the rocket.
Made it.
Falcon 9 first stage is also equipped with 4 landing legs, and we make those using state-of-the-art carbon fiber with aluminum honeycomb.
Today we are learning about hydraulics, but first we're taking a look at SpaceX's Falcon 9 launching another 60 satellites into low Earth orbit.
Stage 1 FTS is safe.
So now what's going on? It looks like we got a entry burn.
Right, so this 20-second burn has just begun. You can see that there on the left-hand side of your
I
screen.
believe they ignite 3 of the 9 Merlin engines.
Look closely, you might be able to see those grid fins actuate to assist
Stage 1 entry burn shutdown.
steering of that.
And the grid vids are just at the top of the rocket. It just like they stick out like this, and it kind of
That is the
they
first
use
burn.
them to kind of steer because it
That's
works
the first of
as
2 burns that
like
first
a
stage will
drag
perform today.
force.
Good news there that both vehicles are following nominal trajectories. That landing burn will take place in just under a minute.
Hydraulics is cool because of the
Because
way
this
it
landing
affects
is a
nature.
drone ship landing instead of a land landing or return to launch site landing. There's only 2 burns.
Works as a drag factor of 2.
Opposed to 3, because the first stage follows an arc. There is no boost back or
Buttercup, how are you?
there's no boost back or flip maneuver required. So only 2 burns being executed today.
And what's going on
Model
is
there with the second stage as it
we
carries
analyzed
out
drag
that
force
Sterling
for the Model
satellites.
3. Very cool. That's really cool. I'd like to speak with you sometime. That sounds awesome. Not much, Jeff. How are you?
And that landing burn.
Thank you
Oh,
for
we
the
have a
favorite.
shot of the
And we
drone
have a
ship
landing burn
in
coming
position
in.
in the Atlantic Ocean.
Landing burn startup.
Here we go.
And we can see
Landing
that it's
burn.
beginning
You
to
can see it.
illuminate the platform and the waters around.
Stage 2 is under terminal. Stage 1 landing leg deployed.
Okay, let's see.
Can
if
I
we'll
join the
accept
block
this
box and
landing.
blow your mind?
Looks pretty good.
Not during my show, but
And we
yes,
can
sometime
see the
during my
first
stream.
stage has landed. This marks the
I want to be a rocket ship. Yes. What's up, Cuddy? How are you, sir?
And the 5th recovery for that
Yeah,
particular
hey.
that you see there. So that's all
Good
great news for the
landing.
first
Good
stage.
landing.
Turning our attention to the second stage there. Second engine cutoff is expected momentarily.
Yeah, Cuddy Builder is, or what am I saying? Cuddy is the best builder on the app. Bella,
And
Bella,
we're
Bella,
gonna
how are
wait to hear
you?
the call out for good orbit.
I did. What's your take on Dogecoin? I think that I have some of it. I'm. You never know. Like it didn't cost me hardly anything. So I bought a couple thousand shares. I mean, I have Bitcoin. I like Bitcoin. I love cryptocurrency. I think it's the future.
Take a look at this animation showcasing
I
where
encourage
we are in the
everybody
first stage.
to
We'll see you
go
back here at
and
2
get some
plus
Bitcoin.
45 minutes for a second stage relay.
I just sold all my 4,000 Dogecoin. Yeah, why is that? Yes, for sure. Everybody. Anyway, so that was the focus of that. So now I'm going to go over to the first experiment. Sorry, let me just do. Okay. Don't look good. Better to put in Bitcoin. Yeah, Dogecoin or whatever the heck it is. It doesn't matter. But hey, if you're just joining us, this is Weird Science, and I'm your host, Mike F. Bell. We just saw the launch of 60 satellites to low Earth orbit as part of the SpaceX's Starlink network. Woo! To the moon. Thank you. Starlink is a system that SpaceX has actually they're putting up a network of satellites. Right now they have over 1,000 satellites in low Earth orbit. These satellites are able to go around the Earth and provide internet to places where it was unfeasible before, because the cost is all in that last couple of miles in like rural networks and stuff. That's where getting that last bit of mileage to the people is extremely expensive. But when you look at SpaceX's Starlink, they have a system in place that offers low latency, high bandwidth, and it's something that's gonna just only get better. It's gonna keep on getting better, and I look forward to seeing what Elon Musk is able to bring with it. Neural networks help. Excuse me. So what we have here is we're talking about hydraulics today. Good. Well, you're in the place to be, because this is weird science. Does this have to do with Newton's third law of motion? No, it does not, but it does. Everything does, kind of. That's basically, let's say we got, for every action there's equal and opposite action, and sum of forces is equal to mass times acceleration, and yeah, everything. This is all about conservation of pretty much the fact that water is incompressible. So water is an incompressible fluid. It is the reason that hydraulics work. You can't have hydraulics with air, because that wouldn't be hydraulics. That would actually be pneumatics. So anyway, the thing with water is that it's incompressible. So that allows hydraulics and hydraulic systems to do great amounts of work. So what we have here in the picture is just like two connected cylinders, and one is bigger than the other one. So yeah, it's really there's nothing hard about hydraulics. It's very, very simple. You could actually build one of these, and I'm going to show you how to do that. So anyway, what we have is two cylinders connected, and when you push down on one, the other one goes up. It's the force is equal to pressure, or pressure is equal to force over area. Pressure is equal to force over area. Yes, and that is actually what I'm going to show you, Shauna. It's like, so let's take a look at that. Let's take a look at our first. Thank you, Charisma. I appreciate that. And here we go. We have a couple of things. I have too much crap up here, namely. Anyway, there we go. So you can see this and this. These are two connected syringes. So I got one smaller syringe here on the left, and I hope that you can see that. Nope, I gotta move this, sorry. So what's happening is so I've got two syringes, and those syringes are connected. So when you press down on one, the other one goes up. So that one's down. Well, watch when I press on this one over here. Hopefully everybody's seeing everything. Thanks, Charisma. So watch this. I push on that. Well, I should probably do it with two hands. So yeah, that goes right up, down, and then. And the thing is, with hydraulics, like I was showing in that previous slide, it's all about the fact that that is science. Exactly. Thank you, Charisma. It's like, come on, let's get a big one. Bonus, bonus, bonus. No such luck. No worries. I encourage everybody here to smash that favorite button because you know what? I do this every week. We talk about science, and this is Weird Science. I'm your host, Mike F. Bell, and I hope you're learning a little something about hydraulics. So it's pretty interesting because we kind of made a setup where. Hold on. Here we go. So I'll turn this off. Nope, not that one. This one. There we go. Okay, so now, like, here we go again. Here we go, here we go, here we go now. Yay, bonus. Thank you. So look how much this one rises in comparison to like this one right here. So if I press this, that one just rises slightly. But on the flip side, if I were to press this one, here we go. Maybe now you can see this a little better. See how far that one goes? Like, just like, it's all because this is related to that picture that I showed you just a minute ago. There we go. This picture right here. So what's going on there is I have two different sized volumes or two different areas. So I have the bigger tube and the bigger tube. Let me take this one out. Explain this. So the bigger tube is like this bigger area down here. And this smaller tube, smaller syringe is like the smaller area. So the different volumes and different surface areas. So the fact that water is incompressible, what's going on? Choff, how are you? The fact that water is incompressible, this volume that is in this syringe, when I press it down, it's going to go into here, that same exact volume. So there is something to be said because force is, or pressure is force over area. So when I have a smaller force or when I have a smaller area, it takes less force to raise this one up. So that's why hydraulics work. That's why hydraulics are able to lift things and make it so that you could jack up your car and lift an elevator and do all kinds of neat things. If we didn't have hydraulics, we would be in a sad state of affairs because we use it for everything. They're used in your car, in your brake lines. Your brakes are actually operated because there's a master cylinder that's connected to the rotors through hydraulic lines. And those hydraulic lines, they pinch calipers and squeeze the brake. So it's kind of like like this, just like that. Exactly. They're used for a lot of things. So this is a simple concept. This is something that you can make with well, maybe if it's like water cooled, I was thinking. No pressure. Yeah, it's all about the pressure. And with hydraulic systems, the pressures are able to generate great amounts of force. So, next up, what I have is another demo. So, here we got a jar, and hopefully you all see this good. So I got a jar here with a balloon attached to a tubing. And then to that tubing, I have 2 liter of water. So now what I'm going to do is stand up so I could do this better. So watch how this will lift. Ready? Here we go. And this is all just the force of water lifting this. And like the thing about water too is if I used a long piece of tubing and really lifted this 2 liter up, it would fill so much quicker and you would get a lot more pressure because the pressure is all dependent upon the difference. Yes. Is that hopefully? So what's going on there is that the incompressibility of water is making it so it's able to lift. Again, kind of like a demonstration of what hydraulics are. And welcome everybody to Weird Science Wednesday. I am your host, Mike F. Bell, and today we are talking about hydraulics. You probably may have used hydraulics. Everybody's probably used hydraulics and not even realized it. You have all driven automobile, probably. So you've used hydraulics because hydraulic lines are in your car vehicle in the brakes. So it's pretty interesting. So let's take a look next. I showed you the way that water fills up this balloon and is able to lift. With greater lifting force, you're able to lift more things. So if I was to take a gallon of water and lift it way high up, it would be so much pressure. It would fill something up really quick and be able to lift a lot because water is all about gravity. Yeah, it's all about the potential energy. Exactly. Fabulous. Thank you. So what I got here, if I can get it out, nope. Whoops. Okay, this is gonna show why water is able to fall. Like, it's because gravity. This is the same reason that a siphon works. So watch this. So I got some beads, and then below it I just have another container to catch it. So watch what happens. It all goes right in, and it's because of that gravity. Once I start the beads, they just keep on going. It's very similar to how I'll do it one more time so you can see it again, in case I know it was kind of fast. So I got to lower the beads in here. And then kind of just like a bead. Watch. Yeah, it fell. It fell, and it worked similar to Slinky. Yeah, Slinkies are a little different, but sort of, kind of. What we have here, that's mathematically insane. Not really. Not really. It's like all just science, and it's all about gravity and potential energy. What potential energy is basically the height above ground. So you take potential energy is actually calculated. It's mass times gravity times height. So usually things are measured in mass. For mass, it's kilograms, and then meters, and then seconds. Yeah, it's the way a siphon works as well, because it's the gravity of the beads pulling down. So it's real similar to the way. Yeah, you could actually. It doesn't take more than. I just have some party beads. I thought I had more party beads somewhere. It's like I don't know what happened to them. I must have thrown them. But anyway, the beads, they just go in here. Just drop them in a higher container. It could be a glass or anything. And then just hang a little bit over the side, and then just get it started. See? So Mardi Gras beads, exactly. It's like I don't have a lot of beads because I don't know. I guess I'm a bead giver, not a bead getter. Thank you all so much for the favorites. I 100% appreciate those. I'm your host, Mike F. Bell, and today we're talking about. I forgot what we're talking about. What are we talking about? No, just kidding. Hydraulics. Anyway, one thing that I could show, this is a 0.5 kilogram weight. If I hold it up, this is not a meter, but it's like about a meter. If I drop that, that is equal to 1 Newton. The falling power is more, hold on. Okay, and next I want to show that water is in fact incompressible. So how we're going to do that is I have a vacuum chamber set up, and I'm going to show you balloons in there filled with air versus balloons filled with water. Hydraulic oil. Yes, they use hydraulic oil in hydraulics. The main difference is it's not. Excuse me. The main thing is that it doesn't freeze. It's like if something freezes, then it's gonna be prone to bursting, and bursting is never good. That force I've got a vacuum chamber. You've probably seen this guy because I love using the vacuum chamber. It's the most fun. All right. So there's that one. And a designator. All right. So here we go. Vacuum chamber. And I have another vacuum chamber right here. And another image of this whole thing. It's like I need a cameraman. It's like if I had a cameraman, that would make it a lot easier. Boom. There we go. Okay, so let's go ahead and hold on. I gotta flip one thing around. Okay. Whoops. Didn't mean to do that. Okay, whatever. Fucking, we are off. Let's go ahead and start my vacuum pump. First, let's plug it in. All right, turn the vacuum pump on and watch what happens. I move myself out of the way. So you might notice some things. Like I got some items in here that are starting to fill up with air. Yeah, we are learning. Absolutely. If you're just joining me, this is Weird Science, and we're talking about hydraulics. Right now, I'm kind of demonstrating how water is incompressible. What you're going to notice is that things with air in here are actually going to get a lot bigger and pop, but the water filled balloon will not. It's like you see that pink balloon getting a lot bigger. That's because that one's filled with air, and as the vacuum draws down the air pressure, the air inside that balloon is going to expand. So you see, like it's still going, it's still pumping everything. Like it's that pink balloon is expanding a lot bigger, but the other one. Oops. Let's see if I can get a better camera. There we go. So everybody make sure that you go ahead and smash that favorite button if you haven't already done so. I do Weird Science Wednesday, and I do it every single Wednesday. So look at that. Look at that big. I have some of those Amazon packages in there. Right above my head, you'll see that Amazon package. It's like ready to burst. I'm sure it's going to pop soon. Pop. There we go. That's one down. Yeah, I know. That's like the one package. I got another one in there. Weird Science Wednesday. And smash that favorite button while you're here. Smash that favorite button. I like to send out a blast of when I'm live and keep you all updated. I also encourage you to follow me on Instagram, same as my username, Mike F. Bell. And I thank you all so much for the favorites and the gifts and continuing to hold down those hearts. I really appreciate that. Oh, there we go. There's that other one popping. Good content shows on Neatly. Absolutely. If I don't have a show that is entertaining and interesting, I don't know what I'm doing. Thank you. What pressure or lack of pressure does to the environment we live in? Yes, absolutely. It's pressure is everything. And thanks to water, you notice that that water in there has not the pink balloon is ready to blow up, but the other one, somebody actually did something informational on here, and also love the name Kim Possible. Kim Possible is awesome. She's cool. Pressure, too much groceries. It's like too much groceries will cause pressure. And could also cause a lot of waste. They watch the thing about food waste. We waste far too much food in this country. It's sad. You're loving this? That's all I'm going to say. Well, thank you so much. And if you are loving what's going on, I ask that you smash that favorite button. Hit that star above my head somewhere. It's over there. No, over. Nope. Over there. Somewhere. Nope. There. Artemis, how are you? Good to see you. Next time, a barometer in there. Next time, Mike. I had a barometer, but I screwed it up. Like I had it in there, and it actually whacked it out of balance. So I don't know. You are a star that I quick tan immediately when I got here. Ring that bell for Mike. Thank you for the. There we go. There's that balloon finally popping. It's like it popped into a heart. So yeah, that's you see that that water-filled balloon is still very much there. Let me zoom this in a little bit. No. Yeah, still very much there, and that's because water is incompressible. Well, it is kind of a little bit compressible, but to the extent that you're going to imagine it, it's incompressible. It has to do with the fact that water is. I love the extra screens on stream. I want to learn that too. Well, you could all do what I do. It's all about OBS. Mike. Hi, thank you all for the favorites. Thank you for the roses. Thank you, thank you, thank you. And I'd love to go into teleportation, but I have a limited time here. So maybe on a future stream, or if you want to come onto my stream and talk about it, I'd love to. I hope that you're all enjoying what you're seeing, and we'll be here every Weird Science Wednesday. And you see that balloon, no matter how much vacuum it's under, it is not going to pop. That's because of that incompressibility of water. That same thing that I showed you with the what's that, Robin? How are you? It's the same thing I showed you here with this. It's just knockoff Bill Nye, except better looking, cooler personality, and smarter. I will enjoy your stream. I'm good at relativity and stuff. Wrong stream. Thank you. Well, I totally appreciate everybody favoriting my stream. And you know what? If you could spin those wheels, spin those wheels. Let's go. It's like we need to get some bonuses up in here. Mama, what's going on? Bella would be amazing, but definitely not. Yes, wheels and hydraulics are just a really cool thing. If we didn't have hydraulics, we wouldn't be able to have lifts, hydraulic lifts. We wouldn't be able to have elevators that are capable of lifting great amounts of weight. We wouldn't have excavators. We wouldn't have equipment, heavy equipment. All that equipment is operated with hydraulics, and hydraulics is just a force multiplier. So what I'm going to show you is that the way that hydraulics. What is this? Oh, right here you're looking at a vacuum chamber. I have the vacuum chamber and I had some balloons in there. Obviously the balloons popped. The ones that, yeah, that's right here. And then right here, this is a balloon. This one right here. It's filled with water. And that one doesn't pop because, you know what? Water is incompressible. So that means you can't compress it and you can't expand it. So it's going to be the same density. With air, you have different densities. Yeah, that's a balloon filled with water. The balloon filled with water did not pop, but the other one did. So let me go ahead and shut off my pump for a minute. I'll start this over one more time and give you an idea of what's going on. So I have some balloons here. The hydraulics, it's that water is incompressible. Water is incompressible. And if water were compressible, it would be air. And if it's air, then it's not hydraulics, it's pneumatics. But the What's that, Blondie? Bye. I mean, super funny. Let's go. Let's go. Dolphin. Dolphin. Artemis, thank you. So here, I got another balloon here. I'm going to let this pressure back in. Let that back in. Take out all these balloon fragments. It's like when a balloon pops in here, it fragments into like a million little latex shards. It's actually pretty intense. So there we go. Got that. Have another balloon in there. And fun, let's put in one of those Amazon packing things. There we go. Pop that in there and close this down. We'll go ahead and turn on our vacuum pump. There we go. Put in package of Kit Kats. Those are my Kit Kats. No. Yes, it is a vacuum. Everything is getting pumped down. The pressure in there is reducing. There's no such thing as a perfect vacuum, but you might be able to see what's going on here. So I got a pink balloon, some clear Amazon packing product, and then a blue balloon that has water in it, mostly filled with water. And what I'm doing is I have a vacuum chamber. So that vacuum chamber is reducing that pressure. The gas that's inside of the balloons and that packing bubble are actually expanding. So what's going to happen is you're going to see probably that clear packaging pop first. So watch, you're going to see it. You're going to see this, it's blowing up and it's getting ready. It's just a vacuum chamber. It's just spherical. And what I like about this one, rather than a bell chamber, it's plastic instead of glass. No, it is a desiccator. It totally is a desiccator. Thank you. Yes. I see. Balloon filled with water doesn't explode. The rest do. Correct. Yay! Narwhal. So we're just waiting on this to keep on pumping down and hopefully, oh, come on. Thank you. So what you want to see is the connection of that to the hydraulic. Look at that one. That balloon popped. I'm surprised. The balloon popped before the other one. This is all about pressure. And what I'm showing is that the water-filled balloon, look, there we go. That popped. Thank you for the champagnes. And so what's going on there? It's not popping. That's because, yeah, I got a bonus. Bonus. Yeah. David Bowie under pressure. Actually, Queen, pressure pushing down on me. Yes, Nemo. Thank you for that. And you've probably seen that all the other ones have popped, but this one has not popped. All the other balloons have popped. Yeah, I'm not sure. I don't know. I don't know anything. I'm just a scientist. I don't know music. It's like, ask me about physics, but you ask me a question about music or sports, I do not know it. So if you're good at music and sports and are in the Tampa area and want to sign up for some trivia for a trivia team, let me know. So how does the elevator work? The elevator works the same way. It's just hydraulic lines that are pumping things up and down. So what we have is these. Push down one, the other one goes up. Now I push down this one. Watch. Just like that. It's pretty cool. And hydraulics are in use all around us. In our cars, in elevators, some elevators. You can only have elevators that go a certain height. You can't have them over a certain height, otherwise it doesn't work because of that pressure. Thank you for the favorite. What's up, Alice? How are you? It's all about push and pressure. Oh, and one thing that I want to talk about real quick, finally, before I say goodbye for the week and see you next week, is that here we go. All right. And so, what's going on? So I got two. You probably can't even see this because I need to probably show you this camera. So these are the two different weights. Kind of like it takes a lot less weight to push up this one. So this one's got a bigger mass, and this is kind of like the pressure and hydraulics. Anybody could be a scientist, honestly. All that it takes to be a scientist is to have an understanding of the world around you, a thirst to want to understand the world around you. It's why does this happen? Why does that happen? When you begin to question things and ask why it happened, you become a scientist. Your cat probably is not a scientist. Well, thank you all so much for joining me. I had a great time. I am nearing the end of my hour. Thank you. And if anybody has any questions, now would be the perfect time to ask those questions. I agree. Ha! Yeah, science is awesome. I get thinking about the feather that snapped in space in the 90s. I'm not sure. Thank you. Hey, Fabulous. Thanks for the info. And everybody here, make sure hit that favorite button, smash it. Those hearts down. And thank you for the favorites. I'm Mike F. Bell, and this is Weird Science. It's been fun as always. Hopefully, today you've learned a little bit about hydraulics and why water is incompressible, and hydraulics are used all around us in order to make a force multiplier, and it allows us to lift great amounts of weight. It's all about the pressure and the incompressibility of water. I hope you all had fun. Well, I probably didn't explain it well enough for you to understand it. It's okay. Maybe some other time. Bazinga! There's no worries, though. You don't have a face, so. Mr. Fantastic. I still have Harry, so. First timer. We'll see you next week. Thank you so much, Batty. And thanks to all my gifters today. I really do appreciate it. Your gifts definitely help me with getting my experiments and funding my future experiments. Betty. Bye, everyone. Thank you all for showing up on time and leaving on time. Who says that you need to leave? Somebody kick Fabulous Trophy Mail. Guess what? You're a bouncer. Bye, Fabulous 63. No name. Did that work to set you as a bouncer? I hope. It was a fabulous show. And I totally appreciate everybody turning out and coming by and saying hey. Your favorites and your support make this whole endeavor worthwhile. Click on the person and then kick them. There you go. Kick little Fabulous. Fabulous 63. It's funny. Lame. Thank you, Emoji. All right. Anyway, I am ending my stream now that this guy is gone. So I hope you had a good time. I hope you learned, unlike Fabulous 63. Kick the wrong person, Fabulous 63. What's going on? Somebody needs to kick Fabulous 63 out right now. There, I set you as a bouncer. Yeah, red guy, you suck. You may have to leave the stream and come back in if it doesn't work. It's famous 60 or Fabulous 63. Pick Fabulous 63. They don't have a picture and no, not Inertia. Fabulous 63. Fabulous 63. All right, whatever. It doesn't matter. Who cares? Trolls will be trolls, and it doesn't matter. Next time, bouncers be on point. Oh, Fabulous was Inertia? Okay. Okay. Well, Mr. Fantastic, do you want to be a bouncer? I'll make you a bouncer. Just make sure you gift me. Oh no, didn't do the right one. I almost blocked you. Jeez. Oh wait, that's not the right thing. I need to do it from here. There you go. All right. Well, I'm in my stream. It's been fun. I look forward to coming back on later tonight. It's like you guys are awesome. Thank you all so much for the gifts. Thanks to my top gifters, Batty, Robin, and Rebecca. Thank you all for coming in, and thank you for your viewership. Thank you for your comments, questions. I will see you all next week. Bye, guys.